So this question is a dynamics question, actually. They ask us to find the acceleration. So it does not have to do with energy, but it has to do with dynamics. So we'll analyze the forces on this mass, and it'll have a gravity downwards, and it'll have the spring force upwards. Now, how do these forces compare? Which one is bigger? So let's see here. It says at a specific moment of time, it's stretched by 5 cm. And so it asks us to determine the acceleration. It does not tell us which way it's accelerating, so we're gonna have to solve that as part of the problem. So what I'll do is I'll go with Newton's second law. I'll use vector form. I don't know which one's bigger or smaller, so it does not make sense to use the magnitude form. So I'll go with vectors here. It's the sum of these two vectors. The net force is going to be mass times acceleration. And the spring force is going to be k times x. And it's going to be up, because it says the spring is stretched. So since it's stretched, it wants to go back to its natural position, which would be a pulling force. It would be pulling up. Whereas gravity is mg, and that's going to be down. Gravity is always down. And so basically, when we calculate it, whether it ends up being up or down is going to determine the direction of the acceleration. I'll divide both sides by the mass, and I'll also fill in the values while I'm at it. So the k value, the spring constant, is 300 newtons per meter, whereas the x value is 5 centimeters, which needs to be changed to meters, because meters needs to match up with the newtons per meter that k is given in. And mg, so the mass is 2 kilograms. G is 9.8. And once again, the first term is up and the other one is down. And I'll divide it all by the mass. So when I calculate some things out, so I'll do the first term, 300 times 0.05. That's going to be 15 newtons up. And then 2 times 9.8 would be 19.6 newtons down. So at this point, I know that it's going to accelerate down because there's more downwards force than upwards force. And I find the overall force, which would be 4.6 newtons down. And then that's divided by the mass to calculate the acceleration. So that'll give me 2.3 meters per second squared. It'll be down.